Hey guys, let's discuss WhatsApp system design today with AI feature in it. So the first one will be functional requirement. Okay, so functional requirement is divided into two parts: core messaging and AI feature. Okay, core messaging and AI features. So in core messaging, see the basic requirement is user will be able to do one-on-one messaging. Okay, then group messaging also. For group messaging, the size should be 1024 user. That could be the limit. Okay, maximum 1024 users could be in a group. Then media messages, like user should be able to send image, video, audio or documents. Okay, and then he can see the online or last seen of the user. Message delivery status also, single tick, double tick, blue tick. Okay, three types of ticks. Then typing indicator, when user is typing writing something, so other one should see the typing indicator that user is typing. Then read receipt. Okay, and then push notification. If user is offline, then he should get the notification. So that is the push notification. Now AI feature, what AI feature you can include here is smart reply suggestion. Okay, if someone has messaged you, then it should pop up the reply like yes, no, maybe later to you, and then you can choose one of them. You don't need to open and then write something, right? Auto language translation, spam detection, toxic messaging filtering, smart group summary. Okay, it should give, let's say in a group someone has sent 500 messages. Okay, there is a conversation and 500 messages are there. So when you open it, and so you should see this smart group summary that the meeting is scheduled to tomorrow 5 o'clock. Okay, so something like that. Then voice to text transcription, you're saying something and then it will transcript it. Okay, to text. Then AI message prioritization. So AI message prioritization means, let's say lots of messages came, new year messages for example, so he should be able to prioritize it, like the typing indicator. For some time he can down that service, like the text to message should be sent first, and then media is on second priority, something like that. Okay, prioritization. Now non-functional requirement here will be that low latency, less than 100 millisecond, this one message should get delivered. Okay, when you open WhatsApp, you should not see connecting this thing icon, right? And then availability, high availability, 99.99% time it should be available. Strong message durability, your message should not get lost. Okay, and then horizontal scaling, end-to-end encryption. End-to-end encryption means user is sending the message, it will be encrypted. Okay, and then server is storing it in an encrypted form only and will send user in an encrypted way. Okay, even server can't see the this thing, the response, the messages, and then receiver will decrypt it. Now support billions of messages per day. Okay, scale estimation, if you talk, so let's say you have a 2 billion WhatsApp users. Okay, in which daily active user is 800 million. Okay, after that average message per user per day is 40. One user is doing 40 messages per day, so it means that you have 800 million user and 40 messages each user is doing per day. So how much it would be? 32 billion. Okay, 8 fours are 32, and then 1000 into million, so this is million and this is 1000. So 1 million into 1000 means 1000 million means 1 billion, right? So 32 billion it would be. Now 32 billion, now if you divide it into the number of seconds, so you have 24 hours in a day, and then in one hour you have 3600 seconds. Okay, so it would be somewhere around 3,70,000 messages per second. So this is how this much messages we send on WhatsApp. Okay, so now peak traffic, let's say this message number of messages will be 3 times, so in that case it would be 1 million message per second. Okay, now storage requirement estimation, if you talk about, so you have let's say one message is taking 1 KB size. Okay, text plus metadata, so it would be 32 into 32 billion into messages per day, we know that, right? So storage per day would be 32 million into 1 KB. Okay, so 32 billion into 1 kb, 10 to the power 3. Okay, kb is 3, so billion. Now you can say that this 32 billion, okay, billion means million into 1000, right, and 10 to the power 3. So this 3 and this 3 will become MB, okay, and this one will be 32 million, means 32 million byte, and then 32 million bytes, so 32 so storage per day, if we talk about, so we know that 32 billion messages we are sending, and one message is taking 1 kb. Okay, so it would be 32 billion kb. Now 32 billion kb, you can write it as 32 million into 10 to the power 3, and for kb it would be 6. Okay, so 6 and 3, so 3 and 3 6, so it will become 32 million and MB. Okay, 32 million MB. And now 32 million, you can write 32,000, right? Million means 10 to the power 6, so 32 million means 10 to the power 6 into, it is already MB. Okay, so 32,000, take 3 zeros here, and this 3 and this 3 will become GB, 10 to the power 9. Okay, so now this 3 and this GB will become 32 terabyte, because this is terabyte. You know that 10 to the power 3 means KB. Okay, 10 to the power 6 means MB, 10 to the power 9 means GB, 10 to the power 12 means TB, terabyte. Okay, then 10 to the power 15 means petabyte, PB. So daily storage, you can see 32 terabyte. And then if you talk about monthly, so 32 into 30, 960 terabyte means 1 petabyte per month. And for yearly, it would be 1 petabyte into 12, so this one will be 12 petabyte, right? Means 12 petabyte storage WhatsApp required for 1 year. Now if you include media also on top of that, so and let's say media means your images, audio, video. Okay, so let's say 10% messages are containing media, so average media size is 200 kb. Okay, one media size is 200 kb, let's say. So you have 32 billion messages, right? So 10% of 32 billion will be 3.2 billion, right? And each message is taking 200 kb, so it would be 3.2 into 200. Okay, this one will be 640, and this K, and so this one will be terabyte per day. Okay, if you find it, so 3.2 billion, yeah, this billion and this K. Okay, and yeah, somewhere around 640 terabyte. Now high level architecture, if you see, so see, so you have a client, okay, he's running WhatsApp on mobile, and then he will send the message. It will go to load balancer. From load balancer, it will go to API gateway clusters, and then from API gateway cluster, it will go to chat service, and then from chat service to messaging queue. Let's say he has sending the message to the group. Okay, so from messaging queue, and then from messaging queue, it will go to message store to store the message, so that next time user can again take that message. Okay, durability. And then from message, and then from there it will go to push notification. So push notification, if user is offline, then push notification. Okay, so like Apple push notification, Firebase cloud messaging. Okay, we will use that. Now here messaging flow, if you check, so client will send request to A send message to user B. Okay, so client will send message to API gateway. API gateway will authenticate that client first, and then it will send that message to chat service with the message ID. Okay, each message should have the message ID, that is for sure. And message pushed to Kafka, and then message is stored in DB also parallelly, delivered to receiver via WebSocket. Okay, or acknowledgement sent to sender, and push notification if user is offline. See, this thing is very important. The one thing is WebSocket. Okay, here WebSocket concept we'll see in this video only in detail. And second is push notification. Okay, push notification. So if user is offline, we will use push notification. If he is online, we will use WebSocket. Okay, and it should, latency target should be less than 100 millisecond. Now if you talk about AI layer, so AI layer will be here. See, message is going to Kafka, and from Kafka it will go to AI's processor. And what it will do there on that message, it will generate the smart reply service. Okay, will go that message to a smart reply service for spam detection, for toxic filtering, for translation, and for priority ranking, all these services. Okay. Now AI use case, let's see. So smart reply example. What is a smart reply? User received message, are we meeting tomorrow? Okay, so what suggestion AI should give you? Yes, no, let's reschedule, and then you click the answer. Okay, then that response will go to the user. Spam detection example. So model will check whether this sender is unknown, okay, and then repeated links, he will see that this link is going forward to another users also, okay, repeatedly, and whether this domain is in blacklisted or not. Okay, if it is there, then move that message to spam folder automatically. Group summary LLM. So group with 500 messages, AI generates meeting tomorrow, moved to 5 p.m. John will share document. So means that the group conversation is happening, 500 messages are there. Now you cannot go at from start and then check all the messages, right? So AI will generate the summary for you. Now capacity planning, if you talk about, okay, so capacity we have already talked about the capacity planning. So you would be required 12 petabyte per year. Okay, now here you will use either S3 to store your audio video, and then archival tier also you would be needed. Okay, so once the message is getting older, it will go and shift into the different archival storage. Now database design, if you talk about, you will have a user table which will have user information like user ID, phone number, name, profile pic and all. Message table also, which will have message information, message ID, sender ID, receiver ID, group ID, okay, message text type, and then status also, message status, okay, and then conversation table you will have. So it will have the conversation ID, conversation between user 1 and user 2, okay, and last message when it happens and last updated when it happened. Then group table you will have, so group ID, group name, metadata of the group, created by, created at, and after that group member, okay, so group member, so group ID, user ID, role and joined at. So all these group and member details there. Message ID generation. So how we are generating the message ID? We are using Snowflake ID. So Snowflake ID will generate a random sequence for you. Okay, there we will use timestamp plus shard ID. So shard ID, you know that if you have a we have seen that we would be required a lot of storage. Okay, so for one database it is not possible. We will store these data into multiple databases, okay, on multiple servers, and then we will divide these long database. Let's say you have one table, okay, which is storing your chat history messages. So you cannot have that table in one server. So I will divide that table into multiple chunks and will have that in the multiple servers, and then each chunk I will will give one shard ID. Okay, this process is called sharding, and I will assign one shard ID to each shard. So we will add that. So here it will ensure ordering of the message. See, here ordering is very important, right? It should not like I'm messaging someone and then he is getting my first message at the last message at the first, something like that. It should not happen. So ordering is very important in WhatsApp system. Then unique ID, we want unique ID for the message IDs, okay, and then horizontal scaling. We know that the shard one. So Snowflake's, let's talk about Snowflake's ID. What is that? So originally designed by Twitter, okay, and it is a 64-bit unique ID generator used in distributed systems like so this is something like this, 64-bit it would be. And then the structure of the Snowflake's ID will be something like this. So timestamp when the message sent, okay, and then data center ID and machine ID. See, till here it is not unique because at the same time you can multiple user can send the message, okay, so for the same data center and for the same machine. So here Snowflakes will generate the random sequence number which will be unique, okay, so we will append that. So 41 bits is stored is reserved for timestamp, 5 for data center, 5 for machine ID, shard ID, or 12 for sequence number. Now real-time delivery. So now let's talk about WebSocket in detail. Okay, WebSocket is very important in WhatsApp designing system. Okay, here we are using, see, you have HTTP and WebSocket, two types of connection, okay, and then HTTP also you have a variation HTTPS. So we will talk about HTTP, HTTPS and WebSocket here. So WebSocket, why we are using WebSocket here instead of HTTP? Because WebSocket is persistent connection. You don't need to connect again and again, okay? And then it is a low latency, it is very fast. Bidirectional communication, okay, from client to server, server to client. So if user is online, see this one I told you earlier that if user is online, then we will use WebSocket. If he is offline, then we will use push notification. Push notification, when you are not logged in, you will get that message on your mobile screen, right? Notification, that is the push notification. Now see, if you talk about HTTP is very simple, okay? User is sending request to server and server is responding, and then that's it, connection closed. And then again, if I need to send something to server, again connection will establish. But that is not required in WhatsApp, right? We need a continuous communication. That is how we will do chatting, otherwise it will take a lots of time. So here, that's why we are using WebSocket, and WebSocket is connection stays open here. You don't need to connect again and again. So now HTTP is request, response and close, okay? Think like ordering food at counter. So you go to counter, order food, get food, and counter interaction ends. Now when you want again next time, so you need to go again there, right? So for example, you are opening the website, okay? Browser asks give me home page, server send the HTML, and that's it, the connection is closed. So client is sending request, server is sending response, and connection closed. So use case where we use this, loading the web page, okay, REST API and static content. For that we are using this HTTP. Not good for real-time updates. Real-time updates like trading apps you want, okay, live data streaming, live cricket match you are watching. So there you would be required WebSocket. Now HTTPS, if you talk about, so this is similar to HTTP. It's just the message we are sending over the network in a tunnel, secure tunnel. That's it, okay? So same as HTTP but secure. So same as HTTP but inside a logged tunnel. You speak to counter person but inside soundproof secure room. So that is HTTPS. Okay, no one can hear your data. Same as HTTP, client is sending the encrypted request, server is sending the encrypted response, and connection closed. Okay, so example, for banking sites we are using HTTPS, for login page we use HTTPS, and for payment page we use HTTPS. So HTTPS is HTTP plus SSL encryption. Now let's talk about WebSocket. Okay, so WebSocket here. So in WebSocket, this is the persistent real-time connection. Okay, think like phone call. So you call once and keep talking continuously. Client connects, okay, connection stays open, both can send message anytime. So client to server, server to client, always connected, okay. We use this in WhatsApp chat, live stock price, online gaming, and live notification. Now WebSocket communication. So what is the communication steps? What happens? Nothing, okay, just handshake. So see, the client send HTTP request. First time the client will send HTTP request only, okay. So now handshake start process step will come. So client will start with the WebSocket start with HTTP request, but the request will be something like this, that client will ask server that I want /chat get messages, okay. I'm using HTTP 1.1 protocol. Now host will be example.com, okay. It will go to DNS, will check, will take the IP address and will redirect there. And then but here the client is saying upgrade to WebSocket and connection is upgrade. So this two line is very important. So here WebSocket will know, okay, this is not normal HTTP and I wanted to convert it into the WebSocket. So now this going forward, this connection will be WebSocket, okay. So secure WebSocket key and it's a version. So important header is upgrade and connection. So this means that switch this HTTP connection to WebSocket, okay. First time it will be HTTP, but with that he will send a few more detail and then WebSocket will come to know, okay, I will switch this connection to WebSocket now. So server will accept the WebSocket upgrade thing, and then he will reply HTTP 1.1, okay, 101 switching protocol, upgrade WebSocket, and then connection upgrade, and then secure WebSocket accept this status 101. 101 means switching protocol. So now connection becomes WebSocket, and from going onwards, okay, from here you don't need to do again the connection becomes persistent. So after handshake, no more HTTP, direct TCP connection, okay. Now here you will use TCP and bidirectional communication. So client to server, server to client, always open. Now client send message. Okay, so let's say client send hello message and server receive that instantly. So, why instantly? Because now we are not doing the connection again. Server pushes message, no request needed. So server new notification. This is why WebSocket is real time. Okay. Now here you will ask me that till what time this connection will be open. It cannot be open for entire life, right? So there would be some timeout, or and how this will ensure that this timeout means this will get connected. So using ping pong. Okay. Keep connection alive. So it means that to prevent timeout, server will send the ping message and then client will send the pong message. Okay, so it means that keep connection active. Now if they wanted to close the connection, then what they will do, either side can close. Okay, client can also close, server can also close. So client will close frame and server will close acknowledgement. So connection will get closed. Now let's talk here about HTTP and TCP. Okay, so HTTP will work on see, many people confuse here. TCP is lower level and HTTP runs on top level. I have also explained this. So you know OSI model. Okay, so OSI model is like physical layer, physical network. Okay, then data link, then transport, then session, okay, and then presentation, and then application. So it's like means data link, data layer first come and then network will come. Okay, so it's like please do not throw sabzi paratha away. Seven layers you have. So this one will come in OSI layer. Okay, so this is application layer and this is transport layer. So TCP will run on this transport layer and HTTP will run on this application layer. Okay, and these top 4 layer will come into the TCP IP model. So now here TCP is for transport layer. Okay, so responsible for connections. Okay, responsible for connections and ensure reliable delivery, means the message should not get lost. If and then handle packet ordering also it will handle. Okay, and then handle retransmission. If it gets failed, again it will retransmit. So it will guarantee you for the message delivery. So TCP is like a road system. Now HTTP is more like define how data is formatted. Okay, it is more like formatting request response model and uses TCP underneath. So at the end it will use the TCP only. So HTTP is like delivery rules. Now let's talk about TCP and UDP also. So we have seen HTTP, we have seen HTTPS, we have seen WebSocket, we have seen TCP, we are seeing UDP. UDP is so see, TCP is reliable but slower. Okay, it is slower because it is it will guarantee you, it will ordering the packets also. Okay, but UDP is fast and unreliable. So UDP is user datagram protocol. TCP is transmission control protocol. So now here TCP, think registered courier. Okay, so ensure delivery, order maintained, retries if lost, and connection established. So now flow will be something like this: connection established, so it will send the data, it will get the acknowledgement, and then it will close. So example, website loading, HTTPS. Okay, file download. If let's say if the connection network is not working, okay, and then second time again you have reconnected with the network, again it will start from the place where it has left. Okay, again it will download from the place it has left, not from the starting. Similarly for email also, and then database connection as well. Okay, so we use the TCP there. UDP, so UDP no guarantee for delivery. Okay, it will just it's like you're shouting on the in a crowd, that's it. You shout once and that's it. So it means no guarantee delivery, no order guarantee. Order also it doesn't matter, no retry, no connection setup. Okay, so flows, data sent, done, no acknowledgement also. So example like live video streaming and online gaming. Okay, when you are watching cricket match, you cannot go back and then check, and some things you check that, but here in UDP that's not the case. Now media upload flow. So media upload, user is uploading, let's say, one photo, user is sending one photo. Okay, so media service will get called, it will go to S3. Okay, it will store that media in the S3. It will get the URL that where it has it has stored in S3, and that URL will send to message. So let's say there is a user 1, okay, there is a user 2. Now they are sending messages, okay. So he has sent one message, one image. So in S3, that image will go and store. This S3 will return the URL. When the user click on that button download, so it will get downloaded from S3. So this is how your message, your image or audio video will travel in the will get stored in the WhatsApp. End-to-end encryption, if we talk about, so it means that client encrypt message, okay, client is encrypting message and stores on the server in encrypted form only, and then receiver will decrypt it. So this is server never see the plain text, okay. So this is end-to-end encryption. Now sharding strategy, as I told you that we need to store this data into multiple servers, okay, multiple shards. So shard by we were sharding it by hash key, okay, hash user ID mod n, and then what will be the benefit? Even distribution and scalable writes. So you can add multiple shards and then you can write many messages. Now AI model architecture, if you see, so first you will have a Kafka. From Kafka it will take the data, okay, and then it will extract the feature from that raw data. It will convert it into the feature, okay, like user how many times he's sending a message in 1 second and something like that. And then that feature will go and store in a feature store, okay. Here it will be the feature store, and then from feature store we are sending data to the ML model, and then there he will do his calculation, okay, and then training and all, and then it will send that data to inference service and then smart reply API. So inference service, what it will do, it will take the action in real time. Like for example, if spammer is sending the message, ML will say, okay, this is spam detection, so he will just put that in a spam folder. So that is the real-time inference service will do, okay, real-time action it will take, okay. Now next is, so here we will be talking about 31 points, and currently we are on 16th point, okay. Yeah, one more thing. So what ML model we will be using here? NLP model we will be using spam classifier and translation model, translation for translating voice to text and this kind of things, okay. Now read write pattern here. So let's say that your system is write heavy, right? Everybody is writing the logs, and also it is read heavy as well, because everybody is writing the chat and everybody is reading the chat, okay. So in that case, let's say you have a write 1 million per second and you have a read 2 million per second. 1 million because let's say you are writing in a group, so you are sending one message in 1000 people group. Now 1000 people will write it one message, okay. So we will use here Cassandra or DynamoDB, and then this one will be append only storage. Now what is append only storage? So we don't we never update or delete existing data, we just append or add new data at the end, okay. So we will not delete the messages here. Now let's talk about the trade-off of this system, okay. Trade-off means if you choose one, you need to sacrifice another thing. So here we are choosing WebSocket, but it will have a connection overhead, okay, that will be expensive. We are using here AI layer, but definitely there would be an extra latency because AI will train the model and all those things will happen. End-to-end encryption we are using here, so harder moderation, okay, you cannot moderate it. Now sharding, so complex queries, okay, will come. Now Kafka you are using here, so operational overhead will come. So now what all the bottlenecks are here? See, the first bottleneck is message Fanout for groups, means the same thing. One person is writing the message and it will go to 1000 people, okay. So it means that you need to create the copy of that message 1000 times, okay. And then WebSocket connection limit. Now you will have one, if you are connecting with one user, it means you are taking one WebSocket connection, okay, you are acquiring that. Now media upload bandwidth, if you are sending one image to multiple users, okay, it will take the bandwidth, lots of bandwidth. AI inference latency. Okay, AI will take few time. Now here is the simple one line solution for each bottleneck. Okay, so for message fan out, what you can do, you can use queue. Okay, just put that message into the queue, and also batch delivery. So for 1000, just create a batch of 200 people and then deliver them. And also, so message is distributed gradually and not at once. So at once you don't need to send 1000 people the message. You're sending it to queue, and then from queue it will get delivered in a batch. Then WebSocket limit, so distribute user across multiple servers. Okay, connection sharding we are doing here. And then after that, media upload bandwidth, so upload files directly to cloud or CDN instead of application server. Now AI inference latency, so use caching, okay, plus async processing, so AI doesn't block real-time flow. Now here the optimization is also saying the same thing. Okay, now example, if you take example, so message user A send hello to group of 1000 users. Okay, so message is stored once, fan out to 1000 users, and then on, if it is an online user, then we'll use WebSocket. If he is offline user, we'll use push notification, AI generate summary after that. Okay, so final architecture, if you see, so user client will send the message, it will go to load balancer, then from their API gateway, then chat service, and then Kafka, and from Kafka it will go to storage. Let's say we are using Cassandra here. Okay, after that AI will also use that data, notification service will also use that data, and media service will also use that data to store media on S3. Now why this design we are using? Because it handles billions of messages. Okay, that's why we are using this design. AI powered intelligence, it has horizontal scalable. Okay, you can just add multiple servers, and then you can cater more users. Low latency delivery, secure encryption, and high availability. So now multi-region design is also one thing. What is multi-region design? See, if you have customer, means you have users from US, India, okay, Europe, then in that region, okay, just have the Kafka cluster in all the region instead of having one Kafka cluster. Okay, and then cross region replication you can do. Means US, let's say I'm sending one message to US person. Okay, so it will go from India to US region. No, just create one replica of my queue, okay, to my Kafka to US region also. So first time, see, it will not help you. Means I'm sending one message to user, US user, it will take that time only. But second time when I reopen the message, it will come from the local region. Okay, if US person will open the chat, then it will come from US region cluster and not from the Indian cluster. Okay, so that is the thing. Reliability also it will ensure. So let's see all those things here. See, for simple message hello without cross region, so Indian user will send from Indian server, okay, to US user, so works fine, message delivered. With cross region, what will happen? Indian user will send Indian server, and then from there to US server, and asynchronously it will replicate to US region also. Okay, asynchronously, so user will not face any delay there. So yes, delivery time is similar. Okay, then what is the use of this replication? So delivery time is same, but cross region still helps three important cases. The three important cases, all those three are faster read later. Okay, so when US user reconnect without replication, fetch from Indian server, which will be slow, but if it is a replicated, then it will read from US itself. Then regional failure safety. So what is regional failure safety? If India region crashes, okay, without replication, message lost. But if it is replicated to US server, then message is still there. Now local history sync, if you talk about, so when US user open chat, okay, so without replication, cross region read each time, and with replication it will read from local DB, so it will be faster. Okay, so simple rule. Real-time delivery, you no big difference, but history, reliability, scaling, in that point of view, yes, it is a big benefit. Let's talk about control plane and data plane. So we will divide our data into two planes. One is control plane and second is data plane. Control plane will be lighter and data plane will be heavier. Okay, so means all the lighter information we will be putting in a control plane, like user metadata, group metadata, routing information, okay, AI configuration and feature flag, these kind of things. But data plane will have message delivery, media transfer, and WebSocket communication. All these things will be on data plane. So why we are separating it? So we are separating it to improve reliability, independent scaling, and failure isolation. Okay. Now group message fan out strategy. So let's say you have a group with 1000 users, okay, and 1000 writes, then you need to do. So what will be the solution? So two things are there: fan out on write and fan out on read. Okay, so fan out on write, what we do there, write messages to each user's inbox. So this one will be the faster read, when the user will get that data directly because it is coming from his inbox only. But it will have a heavy writes. You need to write for 1000 users, right? What is fan out on read? So fan out on read is store message once and user pull that message. Okay, so this one low writes, you don't need to write much, you are writing at one place only. But yeah, it is a slower read because every time each user will come and he will pull the message and then he will read it. Okay, so what WhatsApp is using, he is using hybrid approach. Okay, so for small groups he is using fan out on write, and for small groups, larger group, he is using fan out on read. Now consistency model, which consistency model we are using here? See, we need to maintain the order of the messages, so it should be strong consistency. Okay, but at global system it could have a eventual consistency. It means that if user is sending messages, then instantly visible to locally, okay, local users. But if for other region, it can sync later also. So here the trade-off is consistency versus availability. Now what is back pressure handling? So back pressure handling is the problem sudden spikes. Let's say New Year messages, suddenly it is spiking. Okay, so what will be the solution here? Kafka buffering. Okay, you can use the Kafka there. Messaging queue, you can have the place the rate limiting there. Okay, you can use the queue throttling. Queue throttling means limiting how fast messages are processed from a queue to prevent system overload. Okay, so you just put some limit on the queue as well. And then drop typing indicator first. Okay, typing is not required. That priority messages, so like for example text will be more, we will give the more priority to text messages than any media, audio, video or something. Okay, we can deliver that later. And then typing indicator, that is also on the lowest priority, and then read receipt also on the lowest priority, so we can ignore that if the load is high. So the first priority will be for the text messages. Now talk about your reliability. SLO, SLA. SLO is service layer objective, SLA is service layer agreement. Okay, so here if you talk about SLA, so it means that 99.99% the system will be up. That will be the SLA. Because see, if you're opening the WhatsApp and it is showing you reconnect, then you don't like that app. Okay, you're sending message to some user and it is telling you sending, then you don't like it. It should send directly. Okay, you should get that tick instantly. So that is the SLA. And now SLO. So SLO is service layer objective. Okay, your internal goal to achieve that SLA. So it means that, let's say latency SLO is P50, 50 millisecond, means 50% messages we will be sending in 50 millisecond time. Another P95, 100 millisecond means 95% of messages we will be sending in 100 millisecond. And then P99 means 99% of the messages we will be sending in 200 millisecond time. Okay, and error budget will be 0.01% failure allowed. This one should we need to achieve. So that will be the part of service layer agreement. Now cost estimation, if you talk about, we know that you would be required, let's say 700 TB per day. Okay, and S3 cost is something like $0.023 per GB. Then in that case you would be required 7 lakh GB into $0.023. It means that $16,000 per day is the cost. Okay, so monthly would be $4,80,000 will be the cost for the storage itself to maintain the WhatsApp system. Now deployment strategy. So how you can deploy it? You can deploy it with multiple ways. Okay, so first let's talk about the microservices we are using here. The first one is chat service. Okay, send receive messages, it will handle. Presence service, so which will tell you whether the user is online or offline status, users online and offline status. And media service, which will just store and get the URL for you, image and video upload. Okay, then AI service you will have, which will have the features like smart reply moderation and all those things. So now here, if we talk about the deployment strategy, we can use Kubernetes here. Okay. Second is auto scaling. Third one is blue-green deployment. Then canary rollout. Okay. Now what is Kubernetes here? So Kubernetes will manage the containers automatically. Let's say your application, you have a container, and inside container you have a ports. Okay. And inside ports your application is running. Let's say you have this user service. Okay, you have this chat service, presence service, media service, AI services running on each pods. So Kubernetes manage the container automatically. It means that it handles the deployment, okay, of the container, and then restart if crash. Load balancing also and scaling, all these things will be taken care by Kubernetes, and Kubernetes manage all the services. Example, chat traffic. If chat traffic is high, then he will scale chat ports. Okay, he will just create more pods here, which will serve the traffic. And then if AI low traffic, then keep fewer pods only. Now auto scaling, if we talk about, so automatically adds more server when load is increases. Let's say if user is 10,000 only, so 3 pod is working fine for them, but if it became 1 million, then it will increase the pod automatically. 50 pods, okay, will serve the traffic. Now so no manual work is needed, automatically Kubernetes will manage for you. Blue-green deployment, so let's say you have a 2 environments, okay, and blue environment is your old version and green is your new version, your latest update, latest changes are there in the green version. Okay, so user currently they are running on blue version, okay, v1, and let's say you deploy on the green version, and now you switch the traffic to green. Okay, if anything wrong happen, then again you can switch to blue one, and later you can delete blue. Okay, because that one will become the green, correct? Green will become blue, blue will become green later. So now canary rollout. So what is canary rollout? Release new version to small percentage of user first. So let's say 5% user, we will they release the new version, and if everything is working fine, then we will do the 95% user to the old version, like piggy bank, what it is called, piggy bank release. Okay, something like that. So if safe, increase gradually, so 5 to 20%, then 50%, and then 100%. So you are reducing risk. Let's say you have a customer from the region which is important customer. So first you will select few customers which your application is deployed to multiple regions. Okay, so you first choose the customer which are not that much, means every customer is important, but which will have not much effect. So you can deploy to that one first. If everything is working fine, then you can deploy to another region. Okay, gradually, not once only. Okay, all in once. So now failure handling. So how you are handling the failure here? See, if your Kafka is down, you can use local buffer. Local buffer means temporarily store data in the service memory or disk. Okay, and when Kafka is down, and then send them later. And second is if region gets failed. Okay, if region gets failed, then in that case failure to nearest region, because we have a cross region replication there as well. Now if DB is shard or not even cross region replication, you can use the nearest region also. If your DB shard is down, then you do the replica promotion. Okay, the replica will become the master. And now WebSocket connection, so reconnect last offset. Okay, like you're downloading some file and network issue, then again if you connect it to network back, so it will download from the offset and not from the starting. So that was the WhatsApp messaging system. So thank you.